Here's problem 227. A car originally traveling at 30 meters per second manages to brake for 5 seconds while traveling 125 meters downhill. At that point, the brakes fail. After an additional 5 seconds, it travels an additional 150 meters down the hill. What was the acceleration of the car after the brakes failed? So we really have two problems here. We have a car traveling down the hill, and in the first leg it goes 125 meters. So let's write that down. Here's leg number 1. Our displacement is 125 meters. Our original initial velocity is 30 meters per second. And what else do we know? We're going to travel this first leg for 5 seconds. And we don't know our final velocity. We don't know our acceleration. Alright, for leg number 2, the brakes fail, and we go 150 meters. So the displacement for that leg is indeed 150 meters. We don't know our initial velocity. We do know that our time for this leg is 5 seconds. We don't know our acceleration. That's actually what we want to find. And we don't know our final velocity, which we don't need to find. The thing is, to relate what's going on here with the information, we can only apply kinematics to intervals of constant acceleration. So we can only look at leg number 1 and leg number 2 separately. Now, in order to solve leg number 2, we need another kinematic variable. One thing we could do is find the final velocity from leg number 1, and that will be the initial velocity for leg number 2, and then we'll have enough information. We'll have 3 kinematic variables in leg 2 to solve for the acceleration. So that's what we want to do. So we want to solve leg number 1 for the final velocity at leg 1, which would be the initial velocity for leg 2. Using kinematic equation number 2, our displacement should equal our initial velocity plus final velocity divided by 2 times time for leg number 1. Solve this for final velocity. So final velocity will be 2 times displacement x1 divided by t1 minus v naught, just with algebra. So this is going to be equal to 2 times 125 divided by 5 seconds minus 30. So our final velocity from leg number 1 is 50 minus 30, or 20 meters per second. Sounds good. For leg number 2, that's going to be our initial velocity. So now we can look at leg number 2 with initial velocity. We know the displacement, we know the time. We want to find acceleration. So we're going to use this. Our displacement for leg 2 is equal to our initial velocity times time plus 1/2 acceleration times time squared. Solve this for acceleration. So we would have, let's see, subtract a v naught t from both sides, then multiply by 2 and divide by t squared. So acceleration is going to equal displacement delta x2 minus v naught t, all this times 2 divided by t squared. So that is going to be 150 minus our initial velocity is 20, and we're going to do that for 5 seconds. All that times 2 over the time, which is 5 seconds squared. And that is equal to 100 divided by 25, or 4 meters per second squared. So we actually speed up. Once the brakes went, we started to accelerate again and pick up speed with an acceleration of 4 meters per second squared. That's our answer.